Hi everyone, I'm Toby Corbin. My colleague Julie is sat down there. Her role tonight is to tell me when I lie, go wrong, or say anything that we can't possibly achieve. So she'll be shouting out quite a lot during this. What we're going to talk about today is our application metrics for Node.JS. Now this is a suite of monitoring solutions that we create for Node. It's not just one thing. We have a variety of applications all based on the same fundamental technology. It provides, as I said, instant insights into your live performance of application. We've got the short URL on the screen, which will take you to a much longer www.ibmdeveloper.com application node. So I suggest you use that one, it's a lot easier. Now, I'm going to attempt tonight to do 3 live demos, which I know one of them works really well. The other 2 we'll have to see when we get to them. So, application metrics for Node. Very low overhead. So it's a low overhead open source monitoring solution for Node.js. Low overhead being round about a less than 1% impact your throughput. So that's with all the default monitoring switched on. No matter what your application is doing, we ran about a 1% impact. Now this means it's suitable for not only monitoring at the developer level, but also for monitoring at a production level. So once you've deployed your application, you can monitor it in production, and you shouldn't really see an impact unless, of course, your application is maxed out. I said it's a suite of packages. We provide base monitoring, so CPU, memory, but on top of that we have this extensible probe framework. Now the probe framework gives us access to much more monitoring capabilities. So the way it works is, if you require certain modules in your application, so things like MongoDB or HTTP or Express or React, Oracle DB, we can actually monitor those things as well. So it's not just about what your underlying VM is doing. We can actually give you metrics into some of the more advanced stuff you're doing. It's completely open source, this, and we have the ability to easily add new probes. So from the list I'm about to show you, if there's things in there that you use in your Node module on your Node application on day-to-day that we don't currently monitor, you can easily add a new one. So we're accepting pull requests all the time. Now, you don't have to do anything additional to make all these probes work. It's all built into our core monitoring solution. The way it works is, if you happen to be using one of the probes that we also monitor or also probe, then we detect it and will automatically start. There's no additional configuration. The configuration to use our monitoring stuff is 1 line of code. That's it. So if I quickly show you some of the things that we can do. So this is our app metrics. It is completely open source, completely free. IBM give this stuff away. We use it in our engagements with customers. We have people in development adding to this all the time. It's not just an IBM product. But if you look at the things we can monitor, we'll scroll down. We can do things like the environment, CPU, memory, event loop, function profiling. Function profiling is turned off by default. That's the only one that we don't have enabled straight away. And that is because function profiling is expensive. Okay, you will not have your nice 1% impact to throughput if you've got function profiling switched on. With it switched on, and I'll show you what it looks like, it still works very well, but your impact's round about 8 or 9%. So it's not something you necessarily would want to run all the time, but if you wanted to see what your application was doing as far as what methods are hottest, it's a very good thing to switch on. Then we've got further on HTTP requests, Socket.io, Mongo, MQTT, MQLite. There's a whole list of things that we can monitor, and that all comes for free. So going back to the demo, where would you start? So we've got this fantastic tool. We can monitor everything that you do. So where would you start? So we start with a developer. You're developing your application. You want to know what it's doing under the covers. You want to know any performance problems that are happening. So where would we start? Well, we start with AppMetrics Dash. Now, AppMetrics Dash is our dashboard implementation sat on top of our underlying data collector. So if you think of AppMetrics as being the data collection, everything that sits on top of that uses that data in some other format. So AppMetrics Dash will give you a nice graphical display of what your application is doing for its performance. It's available on GitHub, it's on NPM, and it is 1 line of code to add it. So you require AppMetrics Dash to attach, and that will give you a web-based dashboard running against the application that you wish to monitor. So fingers crossed, here goes demo number 1. So for this, we're going to use Acme Air just as a Node application to run data through. And here is the code. So this is Acme Air. So the first thing we're going to enable is just @metrics dash. So @metrics dash, only change of code I'm putting into my application. Save that away. Now let's fire up Acme Air and let's send a load driver through it. So this is the Acme Air performance test. It's available on GitHub. It's another free open source tool, and we're using that to drive load. So now let's go to Acme Air. So this is what Acme Air looks like. It's a mock-up of a flight application for booking flights. So it's quite simple, has lots of database connections, and we're going to use this as our monitoring application. So where do we go? So @metrics dash gives you an endpoint on your application of @metrics dash. So we've still got our local host 9080, which is where we were hosting Acme Air, and we now have an endpoint of @metrics dash. And the load going through it, we can now see exactly what's happening to your underlying application. Didn't do anything else, just a one line of code. So we can see all the HTTP incoming requests that are being made. If we hover over one of these points, which is always tricky using the touchpad, we should get a breakdown. Go on, give me the breakdown. Have I got the bit right? If it doesn't work, we'll come back to that. So if you were to hover over one of those points, then I could actually get the, there we go, look. So we don't show you every single request because in this load driver, we're putting thousands of requests. You'd end up with a solid blue bar across your graph, and that's of no use to anybody. So what we do is we aggregate it. So each one of these points will tell you how many actual requests happened during that time. In this case, it was 1,489, what the average duration was, and what the longest duration was. So you can see if you've got any HTTP issues with particular endpoints that are taking a long time. We've also got the throughput, so we can see we're running through 800 transactions a second at the moment, I think is what we're peaking out at. We've got the average response time, so the top 5, we'll call them worst performing. So the worst performing endpoints in your application, we've listed them. So which ones are actually taking the longest to respond. Now that's not the same as which ones are being hit the most, because you may have one endpoint that just takes a long time to respond, but the rest are being called thousands of times. But it will give you your top 5 average response times as to which ones to look at. So if you think you've got a performance issue with HTTP throughput, this is where to go. And then moving on, CPU, memory, the heap of your application, what the loop times are, so what the event loop is doing in Node, some simple environment information. Other requests, so if we hover over one of these, we can see we've got MongoDB. So the Acme Air application actually talks to MongoDB database in the back end. So we can monitor that because one of the probes that @metrics gives us is Mongo. So we're able to see all the MongoDB database requests, and in the same as the top one, if I can get the hover to work, oh, I wish this would be better. There we are. That one tells us there was 1,990 events going to MongoDB at that time. And then we've got some socket IO as well. And then HTTP outbound requests. I've actually put a kind of artificial fix in here because Acme Air doesn't actually do any outbound requests. So I've added a line of code to do an outbound request, otherwise this graph would be blank and it looks like the demo's broken. So we've actually got some HTTP outbound requests. There's another tab up here, profiling. So remember I said at the beginning that by default profiling is switched off because it's expensive. So we'll enable that now and we can see what data we get. So from the menu at the top, we can enable profiling. And now what this is going to do is it's going to switch on the V8 profiling for the application and tell us where we're spending all our time. We get a lovely flame graph back. And now what I'll do is this is going to be constantly updating. But just because we now have data, I will disable profiling just to give me some CPU cycles back. Now, each of these is a call stack. Who knows flame graphs, by the way? Anyone come across flame graphs before? A few. Okay, so for those that don't, a flame graph is a graphical way of showing you a call stack through the application, with the width at the bottom being the time from start to end, and as you go up through, it's the call stack. So at the top, everything's very narrow because it's kind of the end point, the end method in your call stack, and as you come down, you can quickly identify which methods are taking the most CPU. Now this is quite blank, but if we click on one of the things, we get the full call stack. So we can see the one I clicked on there was deserialize object. We've got the line of code, we've got the Node application, the Node module it was in. So you can quickly see where your application is spending its time as far as which methods it's in. And this call stack up here was the longest one. So that one was right at the top, we had a construct array, but at the very bottom, we can see it was parser on header. So this is a very straightforward way of understanding where your application is spending its time. One other thing we can do with that metrics is we can trigger a node report and trigger a heap dump. So we can trigger a heap dump to then load into the Chrome 8 memory analyzer. So you can actually then get the dump needed to see where is your application storing its objects, what's taking up the most space on my heap. So that was Node Metrics dashboard, application metrics dashboard. Any questions so far? Yes?
Is this only applying for Node applications, or you can use it for Java applications?
This is for Node applications. Now, so we actually, just to digress slightly, we actually have a version of this for Java and for Swift. We have Java metrics for Java, Swift metrics for Swift, all based on exactly the same underlying technology, all giving you a similar dashboard, where possible, the similar monitoring capabilities. Where they differ is in what capabilities that runtime will give you. But yeah, this is this is Node metrics or application metrics for Node, but we have Java and Swift as well. So we have similar ones, all open source, completely free again. So back to the presentation. So that's how you would monitor your application you're developing. So that's great. We've monitored it on your laptop. We found some problems. We fixed the problems. Where do we go next? Well, we have an API on the data as well. So let's say you didn't want to just sit and monitor the application and look at the graph, as pretty as it is. You may want to do something else. So let's say, for example, you wanted to run a 3-hour test, but wanted to be told automatically when you were running out of memory or when a particular event happens. We have an API on AppMetrics that exposes all the data we collect via this API. And you can then use that to actually trigger custom alerts. So for example, using this snippet of code here, and this is actually all the code you'd need to do this. Obviously, imagine there's a big application built around this. You'd require AppMetrics. We'd get hold of our monitoring object. And then, for example, we could do, when we get a GC, so monitor on GC, so when my application does a GC, I'm told about it. I'm doing some various things here with adding metrics. And actually in this example, if we go to the example, that way, what I actually do with this, and you can go and download this, it's on my runtime, on my GitHub account. What I did here is I wrote a simple application that when the application I was monitoring had a heap size of above 30%, I think, it sent me a tweet. Completely pointless, but it shows that you can do anything. And that tweet, instead of a tweet, it could have been send me a text message, email me, send an alarm, go off, do anything you like. But it was very straightforward. So if we look at the code itself, the code to do this was, there's the AppMetrics code, requiring AppMetrics, getting hold of the monitoring object. Down here, I have when we get a GC.
Can you zoom in?
Can I zoom in? Yes. I've not had my Mac long, so when you ask me if I can zoom in, it may take me a bit of time to work out. I've got to work out how to zoom out now, right? So let's start at the top. So there's the monitoring. So I get hold of my AppMetrics. So by requiring AppMetrics, that automatically starts us doing the monitoring in the background and collecting the data. And then this monitor function here gets me a monitor object that has the API attached to it. So with this monitor object, I can now do stuff, as it were. So let's look down here. So when the monitor object gives me a GC event, I'm incrementing some internal counters. I get the heap data, using that data. And then down here, all I'm doing is I'm tweeting a message if I detect that my used heap is increasing. So effectively, if I detect I'm having a memory leak using the metrics from AppMetrics, I was sending myself a tweet message. But this is how you could use AppMetrics to generate your own events if you didn't want to sit and watch the dashboard. Right. Okay, so on from that. So we've developed our application, we've done it locally, we've written an API, we've seen how it can be used for custom stuff, but now let's say our actual application forms part of a much bigger cluster. We've actually got 3, 4, 5, 6 things all working together, 6 individual Node applications all talking. How can we monitor those? So we've been using Prometheus. Now, who's heard of Prometheus? Cool, that makes my life a bit easier. So Prometheus is a really good way of monitoring or gathering metrics on several running applications. It works by being told which endpoints or which hosted environments you want to monitor, and if each environment you want to monitor has a metrics endpoint, it will gather data from that and display it on a graph showing you what each of your applications is doing in one place. So it's kind of like App Metrics Dash, but with 6, 7, 8 things all on the one dashboard. Now we work with Prometheus because we supply an endpoint for you. So if your application is deployed into a clustered environment and you want to use Prometheus to monitor it, you can simply add AppMetrics Prometheus to your application and we do all the hard work for you. We do all the gathering of the data, we supply the endpoint, and you just have to configure Prometheus to do it. So in the same way that one line of code is what you needed for AppMetrics Dash, it's one line of code for Prometheus. You require Prometheus. So let's see demo number 2. Wrong one. So we go back to the code. Just comment out the dashboard. Now you can have all these things working together. You can have the dashboard going, you can have Prometheus going at the same time. I'm just turning them off because it makes my life easier. Right, save that away. So I've added Prometheus, the same application now, nothing else. So if we now go back to start this running, we'll start it going. Now I've already got running here in this screen a Prometheus server already running. So let's assume we've deployed to a cloud environment and Prometheus was already hosted. So I've got Prometheus running locally here. So I've started my application, I require Prometheus. Let's again send the load driver through it and we'll go back to Prometheus.
You would have also modified that there's a Prometheus.yaml file that you list your endpoints in, so that's where you're telling it to go to different places to scrape that data from.
Exactly, yes, so I've pre-configured it. So at the moment my Prometheus is monitoring Prometheus itself, so this local 9090, and I've also told it to monitor 9080. So 9080 is where Acme Air is running, but we now have a /metrics endpoint that we've added to it ourselves. So we now have metrics there. So we can see that Prometheus can spot that I have 2 applications running. They're both in state up. Prometheus works by pinging your application and pulling data. You don't push to Prometheus, Prometheus pulls. So when it pulls your data on a configured time limit, we're on 15 seconds here. If it finds your application's not there, it can't find the endpoint, the status will change to being down. So it can also be used to see has one of my node clusters effectively dropped. So yes?
Is there an authentication to AppMetrics, or anyone can see my data?
So the data, right, so the /metrics endpoint we were talking about, if we go to this one and this one, anyone can see the data at the moment. So if you were on a system that you had authentication already added to, then we would be behind that firewall. But yes, but bear in mind that the only data we're giving on for Prometheus is system metrics. So it's how many HTTP requests have I had, what's my CPU totals. You can see endpoints being hit, for example, what was coming in here and whether it was a GET, but I don't believe we give away any very sensitive data. But in answer to your question is no, we don't actually have that behind a firewall. That would be up to the individual to configure that. So if we go back to Prometheus and go to the graphs, the things you can do with Prometheus are, let's look at the HTTP total requests. Dun, dun, dun. And if anybody sees it before I do, feel free to shout out. There we go. And graph. So what we're seeing here is you can see all the requests endpoints that have gone through. There's been an awful lot of them, bearing in mind that I'm running an extreme load driver through. But you can see up here all the data points coming through. So someone's going to ask me to make the screen bigger, aren't they? Is that going to work? So we've got, this one was at localhost 9080. So 9080 we know was my Acme Air application. So we know that that data is coming from Acme Air. That one there is 9080, that's Acme Air. That's 9080, that's Acme Air. 9080, and Is that one going to be 9080? It probably is, isn't it? 1990. So that's the Prometheus one. So we're seeing basically two applications running on the one graph. So that's how Prometheus will let you see across your whole application where the load is being driven. Now, you would then take this as a developer and say, okay, I now know on my 6, 7, 8 applications where all the throughput's going. Do you want to optimize that? You'd go back to the dashboard. The dashboard is running on each individual node application, and then you can see the data specific to that one. So you go from the big wide picture and then narrow it down with the dashboard back, because they'll both be working at the same time. So that's how we can work with Prometheus.
You can also use Grafana on top of it.
Yep, so one thing, if there's any Prometheus experts in the room, I apologize now, but the graphs isn't always the prettiest on Prometheus, so you can put Grafana over the top, and in fact if you go to the Prometheus webpage, they show you how to do these things, so you can make some really fancy looking graphs, but it's still using the same data that we're supplying. D3. In fact, our dashboard, Metrics dashboard, is written using D3.
Yeah, so the Grafana dashboard, which is another open source front end that's designed for doing custom dashboards, that actually uses D3.js charts for everything.
So that's that one, and we'll go now to the last one. Open tracing. Anybody know about open tracing? Zipkin? One person. Okay. So open tracing, it's an open standard for letting you track a transaction right through your entire system. So an HTTP request from start right to the end. It does it by having a Zipkin server that will be running somewhere in your deployment. And as your request goes to each of your services, so you come and say, I want to do a database query, and the query takes place, the Zipkin server will be told at each stage where your request is. So you can quickly get a complete breakdown of where your request went through the system, from the original get to any other traffic it generated to the return at the very end. Now, there are various open source solutions already for doing this. Express do one as an example, and you can do it yourself. But the difficulty is how do you correlate across a span? And by that I mean, if you get a request coming in, and as a result of that request, it triggers another request, how do you link them all together? Now, the way it does at the moment is the current way of doing it is you can have a solution that will put open tracing on incoming requests, and one that does outgoing requests. And you yourself as a developer have to do the magic in the middle to tie them together. What we've done with Metrics Zipkin is do it all for you. So we're back to our single line of code again. So by just adding one line of code and running with a Zipkin server, we will automatically add Zipkin open tracing to applications. So if you're deploying into an environment that is using open tracing and you haven't, as a developer, added this to your application so you can trace a transaction through the whole system, we will do it for you. So it means that if a transaction comes in that hasn't already been augmented with open tracing, we will add it for you. If it has been augmented with open tracing already, we will just continue propagating it through the system. But you as a developer don't have to do anything. So let's go for demo number 3. So, whilst I said it is one line of code, I've actually got a few lines of code in for this one, because I've defined a few extra things. I've told my application which port my Zipkin server is running on. 9411 is the default, so I could have left that blank. I've given it a service name of Acme Air, and there's the require. So you actually only need that one. I've just put in a few extra, bits of information. So let's see what this actually looks like in action. So let's stop the application again. We're now going to rerun it with Zipkin and put the load driver through it and go back to this page. So Zipkin. So Zipkin has a very useful feature where it defaults the end time of where you want to get your traces from to be the minute you bring this page up. So I don't know why, but you always have to go in and change end time to be somewhere in the future. It always defaults back to now. So if we make that 30, we can start to see we're getting something called spans coming in. Now a span, if we click on one, shows me that Acme Air made a post. it got a server receive event came in at 1907, 26 seconds at that address, and then it sent a message off 3 milliseconds later to something else, and it sent off to there to do query flights. So we can start to see what the HTTP request breakdown is in our application and how long each actual individual call took. Now that's okay, but that's just a... Let's wait for Chris to finish taking his phone. Finished? Okay. So that's okay, it's just a single thing. But what do we actually do with more detailed data? So if we go back to my that one and go back to the zip, the Acme Air, what I've done is I've coded Acme Air so that if you do a login, it's going to actually do another call, so we can see the concept of a span. So when I click login, that's going to cause the application, as a result of me doing something, to do another call. So if we click login, he says hopefully, so we click login, and we'll do it a couple of times just to be on the safe side, and then go back to my Zipkin machine, change the end time to be in the future, click find traces, and we see 2 spans. We see we've got an Acme Air and a back end. So if I click on that, basically what we see here is that my Acme Air got a GET request. Now that GET was me coming in at this page and clicking on login. So I asked Acme Air to do the login. And then as a result of doing the login, right down here, right towards the end of that login, it caused a request to go off to the back end. So by doing login, actually caused a second transaction to take place for HTTP off the backend server, which was, I've actually created an API called login. So you can now see all the things that your application was doing as far as transactions go, which is very useful for identifying, again, is a single transaction generating tons and tons and tons and tons of work, which you didn't necessarily know about under the covers. So that's AppMetrics Zipkin. Going back, we have a few others as well. So we have AppMetrics StatsD. So we've stuck a connector on that will collect data using AppMetrics and send it to a configured StatsD server using Node StatsD. We've got an AppMetrics Elk. So if you've got an Elk stack, we can collect data using AppMetrics and send it to your Elk stack. You're not just limited to the data that you're getting from application. We can add all the additional AppMetrics data. And that's all the data. That's all the probe data and everything else. Kafka. If you have a Kafka server running, we can send data to that. And then there's AppMetrics ? You're not limited to what we send the data to. You can add anything you like on the end of it. It's just down to your imagination, your use cases. So with that, thank you, and any questions? Yes?
So it's collecting data from HTTP requests and everything.
Yep.
Is there specific servers that it works with, or does it just...
So that's coming in via the probe framework. So the question was, we're collecting data via HTTP, and is it any particular server? So this is the probe framework. So if your application has required HTTP, we will get HTTP, because that's what we Monkeypatch. So if you require Express, we will also work from Express. Under the covers, Express will use HTTP. It all depends what you're using and whether we have the probe framework in place. If you don't, it's a very straightforward case of adding it. We've picked the first 15 or 20 most commonly used ones, but there's no end. It's the same framework. We can just keep building it up.
So we know it works with Express, we know it works with Loopback, we know it works with Happy, it works with Kraken. We expect it works with anything that uses Node's underlying HTTP APIs.
And that's HTTPS as well, not just HTTP, so also with HTTPS.
HTTP 2?
I'm going to say yes. I'll find out at the break time.
It depends which bits of HTTP 2 you're using. Right? If you're using HTTP 1 to HTTP 2 uplift, yes. If you want to know about the new HTTP 2 APIs like Push, it doesn't yet, but I mean, Toby can probably show you the probe framework later.
Yep. Yeah, come and grab us outside at the break time. I can check with the code and how it works.
We did a tutorial once on how to add probes for like the FS package for file reading, right? it takes you about half an hour to create a new probe. The biggest challenge is how long it takes you to test and verify that your new probe works properly.
Yeah.
But actually adding a new probe is almost trivial.
Yeah, because setting up a test environment with everything running in the background that you need to have is not always the easiest thing, and finding the hardware and kit to run it all on. But
It's like we needed to add a probe for Postgres. So the first thing we have to do is start installing Postgres and try and work out how to get it into our test framework and that sort of stuff.
Yeah. Cool. Oh, hang on, one more back, yes?
What's the performance impact of it?
So the performance, that's performance. So that without the V8 profiling on that shows your method profiling, the performance that we monitored it is around about 1% impact to throughput. So we don't measure it in terms of CPU, because that's kind of doesn't really make much difference. Because if your application's idle, we might look terrible. But if your application's doing loads and loads of stuff, then we look really good. So we measure it in terms of CPU. So the way we test it is we max out an application via CPU, measure its throughput, we'll say take Acme Air, measure the throughput, then add in our monitoring and see how much the throughput drops by. And that's how we know.
So that Acme Air application is what the Node foundations themselves use as their stress test benchmark for Node. So we run it at full load, so it's running 100% CPU, and then we turn on the monitoring and see how much the throughput drops. So when it's completely flat out, there's no spare CPU on the system, it drops by about 1%.
Yeah, and that's the same across all of them. The same for our Java metrics and our Swift metrics. The impact's pretty much about the same.
How about any impact on latencies? Like, I mean, of course, like throughput could be dropping, but like latency is increasing.
Not that we notice. So that's our story.
It's like in terms of the HTTP probe. So we are collecting data and we're doing something with it, right? So if you wrote an application that does nothing but sends back plain text hello world, you'd notice the overhead of running it. If you had an application that actually implements a REST API and does some real workload inside it, you don't.
So that's it. If you've got a real application, customers don't notice it working, let's say in production. But if you've set an idle application, then no.
Let's just say it's less overhead than if you wrote it yourself, let's put it that way. Right?
Oh, sorry.
Oh, yeah, okay.
So you have the original AppMetrics package.
Yep.
And then you have all these other dashes
Yep.
and so on. So what is the original package?
So the original package, think of the original package as being the data collection. So AppMetrics has all the probe framework as part of it. It has the API as part of it. So what we do with the other packages is we just require AppMetrics and then do stuff with that data. Be it put it on a dashboard, be it send it to Kafka or to Elk. But AppMetrics itself is where the magic happens. That's the actual core collector. So that forms the basis of everything. So even though you may only be requiring AppMetrics dash, that will be pulling in AppMetrics. So that's what AppMetrics does. It's the core data collector and API.
So all that data just gets stored like in a little file or something?
No, we store it. We do it as it comes in. We transmit and use it straight away. We don't do any storage. It's pretty much instantaneous. So there's no storing away in memory. There's a little bit for doing some aggregation, but generally it's event based. So as the event is triggered by Node, we get it and do something with it. So send it straight to the dashboard. Send it straight to the API. So we don't.
But if you don't use dashboard, for example,
So if you don't use dashboard and just use AppMetrics, then unless you're doing something with the data, it goes nowhere. So it doesn't get stored. So you have to be actively doing it. If you just switch AppMetrics on, it will generate the events and transmit them. But if there's nothing listening to them, then they just disappear into the ether. So you have to be doing something with that data.
Which means that it's not like you turn it on, your memory footprint goes up 50 meg.
Yeah, it's just.
There's no memory, it's what you choose to do with the data.
Yep, that one. You've had two goes.
How do you snoop the messages?
How do we?
How do you collect the messages? What?
So so by doing for the monkey patching, we wrap around, for example, a certain request. So we do a callback wrap around the request. So when that request is happened by your HTTP, we can measure the start and end, and then we just generate an event. So we're just generating a node event. So that's all we're doing. Then we capture the node event and then make it available via a nicer API. So there's nothing that you couldn't write yourself. There's no real magic under the covers, but we're packaging all the nice data together in an easily accessible API and take some of the hard work of collecting that data away from you, so you don't have to do it. You can just use the API. So that's all we're doing. It's just basically using events.
So one thing to add though, in terms of it, is that this works on all platforms.
Yeah.
It's consistent across all platforms, including the IBM and Z. So
Yep, Node 4, 6 and 8.
all Node releases, so it's not platform specific.
Same experience.
So things like the CPU and memory, that's all at the OS level. We're collecting it there, so it's all different.
And same is the approach for the other ones, for Java.
Yes.
Yeah, yep,
So
yeah.
over 20 years experience around Java and Node and pulling stats off memory. So again, we mentioned that this is Java and Swift as well. So we're going to take all the knowledge we have at the operating system level and hardware levels to pull the information and provide it consistently across all platforms.
So,
Yeah.
is the implementation all JavaScript or anything native in there?
No, there's a little bit native. So the bit that actually pulls the underlying CPU for that has to go to native. So what AppMetrics gives you is when you require AppMetrics, we install it from npm. We package binaries up. You end up we pre-packaged to build binaries because there's some C++ code in there. So obviously you can build yourself, but Windows is always a problem because not everyone has a Windows compiler. So when you install, we will give you a pre-built binary of that, or you can choose to install from GitHub and build yourself. But there is some native code in there.
In some ways, you don't have a lot of choice. If you want to know about underlying CPU and memory usage of the OS,
Yeah.
a lot of the GC data comes directly out of V8 itself. There were new hooks added to libuv, actually by our team to allow us to do this. And so we needed to hook into libuv to get the event loop monitoring and so on. So you kind of have to have a hybrid of some C native code.
I mean, ultimately, we would hope to get away from that because we started monitoring with Node 0.10. So there was nothing in the Node API that let us get this data. So we had to start by getting it all ourselves. As Node's evolved, more and more things are being exposed now at the Node API level, so we can get that data. We don't have to drop back to the underlying OS. So, in the future, we would hopefully have no need. But while we support the early versions of Node, we have to have this in there.
I don't actually have a question, but I've got one now. How does it work with containers?
It works with the containers just fine.
As in, does it break out in terms of the CPU usage and stuff like that? Or
So
Some of that's interesting.
So it's a slightly longer answer. We might chat outside at the break, but basically we're getting from what the underlying OS gives us. So it's however the OS, and so for example, when we run in the cloud, we can get some strange results because you're not always sure what your CPU actually is when you're running in a container inside a bigger system. So it's
You can look at the process CPU.
Process
That's what you
CPU,
would expect.
that
System
works.
CPU in a container.
Yeah. So the process is always good, but the system tends to, when you're running in a container in a virtualized system actually isn't so important anymore anyway these days. It's literally what your process is doing, even though we show you system.
We have been doing some work on Java actually to get the maximum heap size in Java to honour the Docker container size. So to do that, we have to know how much memory is actually being allocated to the Docker container. So we found an API that lets us do that, and we've done that in Java, and we're looking at bringing it into the monitoring, because that's just heap size setting stuff, but we're looking at bringing it over.
So I think we've overrun into our break. Come and grab us at break. Myself, Julie, Chris, Andy will be here to chat, so if you want any more questions, come and grab us. Thank you. Cheers.